On to number 10. So this one is asking us, do the series converge, do they diverge, or is it conditional convergence? So one thing to note is this third one can't converge conditionally because there's no minus 1 to the n or anything like that. These terms are always going to be positive. So just something interesting to note. But these two in theory could. So let's see. Let's start with 10. So when you're doing these series, first it's good to eyeball. Do the limits even go to 0? So I have n squared over n factorial, and in my mind I know, okay, the limit of that goes to 0. So I don't get divergence for free. So I have sum n equals 0 to infinity minus 1 to the n times n squared over n factorial. And so one of the few hard rules is I see a factorial, so I do the ratio test. Ratio test. So an is n squared over n factorial. An plus 1 is n plus 1 squared over n plus 1 factorial. And now I take the limit of these and see what happens. So the limit as n goes to infinity of an plus 1, you divide that by an, but that's the same thing as multiplying the reciprocal by the reciprocal because it's a fraction. This is the limit as n goes to infinity of n plus 1 squared over n squared times n factorial, and then here's this trick we've done a lot. N plus 1 factorial is the same thing as n plus 1 times n factorial. And now we look at these limits. First, these cancel, and I'm left with this limit in here goes to 1. This n goes to 0, so this limit goes to 0, which is less than 1. So by the ratio test, we get absolute convergence. N equals 0 to infinity to the n squared over n factorial converges absolutely. Okay. And now we don't need to test anything else. This is why we like to test for absolute convergence first. Because we could have done the divergence test here. Might have been hard to prove it was decreasing. But we get it converges absolutely for, not for free, but this gives us the correct answer. So now for part B, sum n equals, this one should be a 1 to infinity, minus 1 to the n over 2n. So I look at this one, and I say, okay, does it diverge? And the answer is I can't get that immediately. The limits go to 0, so I don't get anything in that direction for free. But an important thing is to be able to look at these things and kind of know. So my mind is telling me that this doesn't converge. And let's think about that. Or doesn't converge absolutely. Because if I look at sum from n equals 1 to infinity of 1 over 2n, that's the same thing as 1 over 2 sum n equals 1 to infinity of 1 over n, which diverges. Okay, so this is a series that diverges, and so this series does not converge absolutely. But we did this one similarly. This equals 0, and 1 over 2 times n plus 1 is less than 1 over 2n. So the sequence is decreasing. The terms go to 0, and they're decreasing. So by AST, the alternating sum converges. So the sum itself that we started with, which is the same thing as this, converges conditionally. Okay. So you might have seen the factorial earlier and say, okay, I must do ratio test here, right? But if you do that, then you're going to get 1 as your final answer for the ratio test, or as your limit. And 1 is inconclusive, so it doesn't give you anything useful to do that. So it's kind of good to have an idea of what to use in what spot. Okay, and now we have sum n equals 3 to infinity of n times n factorial over n plus 1 factorial minus 1. So the first thing I want to do is check for convergence. And so I look to see this either converges or it diverges. So do I have an easy test to check convergence or divergence? Not really. Divergence, like I might want to take a limit, but I've got an n factorial and an n plus 1 factorial. And that n there makes things weird. So I kind of question. But one thing we can do is compare it to maybe an easier to look at series. N times n factorial over n plus 1 factorial. And I'm doing this because in my mind I'm looking at this and it kind of looks like n plus 1 factorial of itself. It looks like these terms don't go to 0. But let's go ahead and put that to the test. I have minus 1, so this is bigger than if I just did this and didn't subtract 1 on the bottom. But now, this is n times n factorial, n plus 1, n factorial. Sorry, no minus 1 there. Right, if I don't minus 1 on the denominator, I'll have an even bigger number. So I'll divide by something even bigger. Oh, sorry. Nope, 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 nope. This would have to be less than? No, that's right. The minus 1 makes the number smaller. Yeah, and I divide by something smaller, I get something bigger. Sorry. Okay. And now these go away. And so I know for sure the sum from n equals 3 to infinity of n over n plus 1 diverges, since the limit as n goes to infinity of n over n plus 1 is equal to 1, which isn't 0. Here I'm looking at a series where the terms are greater. So by the comparison test this time, test the limit as n, or sorry, this sum, because it's even bigger, n factorial over n plus 1 factorial minus 1, this would also have to diverge. And how did I see that? How would I have any idea? Here's an n factorial and an n plus 1 factorial. So in my mind, I'm imagining they kind of go away, except I'm left with an n plus 1 on the bottom. But then there's an n on top that's kind of the same thing as n gets big. Also, you could have used the ratio test on this and it still would have worked out. So maybe I shouldn't say it's the hard and fast rule to always use it. But it still would have worked. It would have just been harder than what we did. And this is 9c. So I'll write that, or 10c. But, oh no, not too bad. C factorials do ratio tests generally. And that's 10.